Now let's talk about some details with hypothesis testing. We've seen that the probability of getting our results is so low that the probability of getting them by chance is so low, then we can conclude that we didn't get them by chance. We got them because whatever our main hypothesis said must be true. Now, first question I want to ask is, do mistakes ever happen? Yes, mistakes do happen. In fact, we can figure out how often mistakes will happen. Now, in general, when we're wrong, we need to admit it. It's horrible when there's people that won't admit when they're wrong. In statistics, it's very well defined when we're going to be wrong in some areas. In fact, so we need to admit beforehand and be prepared to admit it when it comes up. When we set our alpha level to 0.05, that means that there's always a 5% chance of being wrong, of rejecting the null hypothesis, when in actuality we just got our results by chance. So if we conclude that our main hypothesis is true, we've rejected the null hypothesis, and we're wrong, really the null hypothesis was true, this is called a type 1 error. It's seen a relationship that's not really there. Maybe Beep Beep tosses 100 coins and they all land up heads, and we conclude, oh, he does have cookie power, but really it was just by chance, and he doesn't have cookie power. That would be a type 1 error. Another example would be if I'm using a church brochure example. If a church distributes a new brochure and 10 people come the next week and there've never been any visitors before, we can say, aha, it's because of the brochure. But really, it could be because of chance. Oh, that's when um, uh, uh, Tom and Sue brought their entire family for church because they were having a family reunion that weekend. And it was just by chance that they came. If that's the case, we made a false assumption that the brochures really did work, and that's a type 1 error. Another type of error occurs when we don't reject the null hypothesis, but we should have. The type 1 error was when we shouldn't have rejected the null hypothesis, but we did. Here is we don't reject it and we should have. For example, suppose in the church brochure example, the church brochures were effective. They caused people to come to church, but we just didn't distribute it enough to tell. For example, we only did 2 distributions, and on the Sundays after those 2 distributions, visitors came on one Sunday and they didn't come on the other. If we conclude, oh, we can't tell, or no, they don't work, we're making a mistake, because if we had distributed more, we could see that they did cause people to come. So this is called a type 2 error. In our Marinol experiment, if we concluded that we can't tell if Marinol affects appetite, but it really did, that would be a type 2 error. Now let's look at the alpha level and errors. We can choose any alpha that we want. 0.10 or 10%, 5%, 1%, 0.001. We get to choose the alpha level and the chance of making the type 1 error. However, now you might be thinking, oh, well, let's choose a really, really low level so we don't make any errors. However, the lower the alpha level, the bigger the chance of making a type 2 error. For example, suppose that the church, our hypothesis is that church brochures cause people to visit a church. The null hypothesis is that the brochures do not cause people to visit. Suppose visitors come 4 out of 5 times after distributing brochures. And that means that's what we calculated there, that the P equals 0.02. There's a 2% chance that 4 out of 5 times people would come if it was just happened by chance. Now let's ask the question, do we reject the null? Now suppose we chose our normal alpha level of 0.05. The probability we calculated was 0.02. Our decision is to reject the null hypothesis. Now, let's compare this to reality, because our rejecting the null hypothesis doesn't define reality. Suppose the null hypothesis is true, the brochures really don't work. Then we would have made a type 1 error. We saw a relationship that wasn't there. If we conclude that the null hypothesis is false, then we would have made the right decision. Um, the, uh, um, the, the, um, the brochures really do affect it, or cause people to come to church. So that's the alpha level of with 0.05. Now, if we lower the alpha level to 0.01, we make it more stringent, and we get a p-value of 0.02, our decision is to retain the null hypothesis. Oh, we don't know if the brochures work or not. Now, if the null hypothesis is true, that's the correct decision. But if the null hypothesis is false and the brochures really do work, then we make a type 2 error. So we can choose the alpha level, but the higher the alpha level we choose, the fewer type 2 errors we make, and the more stringent alpha level that we choose, the more type 2 errors that we'll make.